Hey guys, welcome back to my channel. Today we are looking at GCSE Chemistry, Topic 8, Chemical Analysis. Before we jump in, if you do have any questions or anything, please feel free to comment them below. And all the usual, like, subscribe, etc. You can now find a playlist with all the GCSE Chemistry videos that I have done and will be doing. I'll only be doing a couple more after this as we get to the end of the curriculum, the syllabus. And yeah, and then I'll be jumping straight into A-level chemistry videos. So if you're planning on doing A-level chemistry next year, then feel free, subscribe so you can keep an eye on them. But let's just jump straight in. So firstly, looking at purity, formulations, and chromatography. So pure substances are a single element or compound not fixed with any other substance. They melt and boil at specific temperatures, which can be used to distinguish pure substances from mixtures. Formulations are mixtures that have been designed as a useful product. Many products are complex mixtures in which each chemical has a particular purpose, made by mixing components in carefully measured quantities to ensure that the product has the required properties. Chromatography is used to separate mixtures and divide information to help identify substances involving a stationary phase and a mobile phase. So separation depends on the distribution of substances between the phases. Then we have an RF value. So this is the distance moved by the substances divided by the distance moved by the solvents. Different compounds have different RF values in different solvents, which could be used to help identify the compound. Compounds in a mixture may separate into different spots depending on the solvent. But a pure something, that sentence did not finish. And you have just a little diagram of what the paper chromatography looks like, which you can kind of have a look at. Then we've got tests. So there are many tests on this topic. So firstly, the identification of common gases. So firstly, test for hydrogen. So using a burning splint held at the open end of a test tube of the gas, and it should create a squeaky pop sound as hydrogen burns rapidly. Then you've got the test for oxygen. So uses a glowing split inserted into a test tube of the gas, and the splint should relight if there's oxygen present. Then you've got the test for carbon dioxide. So for this, you're going to bubble the gas through the limiter. So this is the calcium hydroxide aqueous solution, and it should turn milky/cloudy. And then the test for chlorine, so using damp litmus paper, put it into the chlorine gas, and the litmus paper is bleached and turns white. Then we've got flame tests, so these are to help identify metal ions. These aren't particularly reliable if there is a mixture of ions present, but if it's individual, then it should work. So firstly, lithium turns crimson, or turns to flame crimson. Then we've got sodium turns it yellow, potassium lilac, calcium orangey red, and then copper is green. And then, so the identification of ions by chemical and spectroscopic means. So firstly, we've got metal hydroxides. So aluminium, calcium, and magnesium ions form a white precipitate with sodium hydroxide. Only aluminium's precipitate dissolves when excess sodium hydroxide is added. Copper 2 produces a blue precipitate. Iron 2 produces a green precipitate, and iron 3 produces a brown precipitate. One thing that I've found really helpful with my own revision, and what I've tried to incorporate into this, is like actually representing the colours in their colour when you're making notes and looking at things, so you can kind of try and get it into your head and associate those colours with it. An example kind of reaction is copper 2 plus 2 OH minus, giving you copper hydroxide. Then moving on to the carbonates testing, so react with dilute acids to create carbon dioxide, and this gas can be bubbled through lime water. If it goes cloudy, then the gas is CO2, and you can say that there is carbon present. And then we've got the halides. So first, add dilute nitric acid followed by a silver nitrate solution. Chloride should produce a white precipitate. Bromide gives a cream precipitate, and iodine gives a yellow precipitate. And finally, our final few tests that we're going to be looking at, so sulfates. For this, you're going to add dilute hydrochloric acid, followed by barium chloride solution. A wet precipitate will form when sulfate ions are in this solution. Now we've got instrumental methods, so this is where elements and compounds can be detected and identified using instrumental methods. These are accurate, sensitive, and rapid, so are more useful generally compared to chemical tests, a little bit more reliable. And an example of this is the flame emission spectroscopy. So this is used to analyse metal ions in solutions. The sample is put into a flame and the light given out is passed through a spectroscope. Output is a line spectrum that can be used to analyse and identify the metal ions in the solution and measure their concentrations. So that's everything on this one. Lots of tests, lots of different colours, but I'm sure you'll be absolutely fine. You'll absolutely smash your exam. So yeah, if you have any questions at all, please again feel free to comment below and either myself or your fellow students will get to it. And yeah, subscribe to see what kind of videos I do in future. And of course, like this video if you found it useful. Thanks guys.